So we are on our 6-2 notes. We have decided that we did the first two above this, but we haven't done any more practice since then. We're just going to finish this. Why is it doing that? These quadrilaterals are parallelograms, so we need to solve for x and y. So I need someone to help me. We have to do x first. So who can help me solve or set up an equation for x? Who knows how to solve for x? How am I going to figure out what x is?
Aren't they supplementary?
They are supplementary. Why are they supplementary?
Because the not corresponding, alternate interior angles, or not alternate, like corresponding interior. Consecutive, yeah.
Consecutive. Good. Okay, consecutive. So Allie gave me the statement. She goes, if quad is p gram, then consecutive angles are sup. And if they're sup, somebody else set up the equation for me. How do I solve for x if I know that they're supplementary?
Would it be 6x plus 12x equals 180?
Very good. 6x plus 12x equals 180. So if I know that they're supplementary, I know they add to be 180. Very good, Maggie. So now I can solve. I'm going to add them up. 6 plus 12 is 18x. And then I divide by 18 on both sides, and I just get x equals 10. Okay, great. And I needed x to equal 10 in order to figure out what y is. There's a couple different ways I could find y. Who knows how they want to do it? I needed x first because I'm going to have to use one of the equations or one of the expressions with x in order to find y. Who wants to set up an equation?
I can.
6x plus 3 equals 180.
Okay, Colin. Megan, I'm going to
3y.
Yep. Okay. So we've got 6x plus 3y equals 180. Colin, how did you know that we were allowed to do that?
Because their sides are parallel, so the consecutive interior angles are supplementary.
Very good. I don't even have to write a whole new statement. The one that Allie gave for me on the very first one is the exact same reason we just used. Instead of using these consecutive angles, we use these consecutive angles. But either consecutive angles, either way you slice it, they're going to add to 180. I had to find x first because if I had an equation with x and y, I would not be able to solve. But I can replace x with 10 and I get 60 plus 3y equals 180. Minus 60 from both sides, and I get 120, y equals 40. Awesome. Okay, any questions on that?
Couldn't you also do 3y equals 120?
100%, Maggie, 100%. So I could have gone this way and done opposite angles and set them equal to each other. If I did that, I'd have to write another statement that said, if a quad is a p-gram, then opposite angles are congruent. Yes, Maggie, definitely works. All right, let's move to the one underneath it. I'll keep that up in case anyone's still writing that down. I need to figure out x and y here. Can someone either set up the equations for me or tell me the reason on how we're going to set up our equations? How do I find x and y? I've got 3x. I've got 12. I've got 4y. I've got 8.
You could do 3x equals 12 and 4y equals 8.
Very good, Megan. Why can I do that?
Because they're diagonals, so that means that they're congruent.
Very good. We have diagonals and we know that these are congruent to each other. And this one actually worked out nicely because I can solve easily here. Divide by 3, I get x equals 4. Divide by 4, I get y equals 2. Megan almost got us to the statement, but can someone tell me the official statement I need to write down to talk about these diagonals? What did we write on the front side of our paper that would tell us the exact reason we get to do this?
If a quadrilateral is a parallelogram, then diagonals bisect each other.
Very good, Allie. If a quad is a p-gram, then diagonals bisect each other. You guys need to know these for Wednesday. So if you know them already, give yourself a high five. If you don't know them, you guys study them. Okay, any question on these two on the left? All right, let's move to the two on the right. Somebody else I haven't heard from today, can you either set up my equation or give me my statement? Who have I not talked to?
If quadrilateral is a parallelogram, then opposite angles are congruent.
Very good, Griffin. If quad is p-gram, then opposite angles are congruent. Very good. Can somebody else tell me how to set up my equation?
Is it 9x plus 2 equals 12x minus 34?
Awesome, Isaac. Griffin told me they were congruent. Isaac set them physically equal to each other. They're opposite. This is equal to that. And now we just solve. Minus 9 from both sides, I get 3x. Add 34 to both sides, I get 36. Moved everything to their appropriate sides. Now I just have to divide by 3, and I get 12 equals x. Great job, guys. Questions so far? All right, on this last one of this box, I've got to find x and y. Someone can find either one for me. Who wants to do x or y?
Six x is equal to 90
Whoa, why'd you know that, Griffin?
because opposite angles are congruent.
Very good. 90 and 6x are both opposite angles. So I'd write the same thing that you literally just had me write above. I would say if a quad is a p-gram, then opposite angles are congruent. We can also solve this in the same step. While I'm writing down Griffin's statement, I want everyone else to think about how are you going to find y and what's that statement? Because I'm going to need help in a second. Quad is p-gram. Opposite angles. All right, now that we thought about y, what equation do I set up? Who can write an equation for me?
Would it be 8y equals 88?
It would be, Jane. Why?
Because if a quad is a parallelogram, then two pairs of opposite sides are parallel.
Not parallel.
Or congruent.
Very good. They are parallel. You're not wrong, but that doesn't help us set them equal to each other. Equal means congruent, so keep that in mind. Honestly, we're not really going to use the first statement that says two pairs of opposite sides are parallel. That's a definition, and we'll have to probably remind ourselves that in a vocab section or a true or false, but not necessarily when we solve these problems. Good work, Jane. Thanks for setting that up. Find y, divide by 8 on both sides, so y equals 11. All right. We finished this first box. We've got 2 more little ones to go. Any questions so far? All right, let's keep rolling. All right, I'm given this shape. I see that I've got some parallel lines here. I've got parallel lines here. Because I've got two sets of parallel lines, I've got a parallelogram. And then it also tells me that this angle right here, EFG, is 50 degrees. That whole angle is 50 degrees. That's going to be important to know. All right, let's just get started. The first question says find measure of EDG. What's angle EDG going to be?
50.
Why?
Opposite angles are congruent.
Very good. So I'm going to make Allie tell me why. I'm not going to write it down because it doesn't give me enough room. But Allie knows that EDG is this big angle right here. EDG, and those are opposite angles. It's the entire angle, so they're opposite each other. Very good, Allie. All right, now we got to find X. Who can help me write an equation to help us find X? Tyler, can you write an equation for me? Where is X?
Right next to,
Right here.
yeah, right next to G.
Good. How are these two angles related to each other?
Are they supplementary?
They are. They are supplementary. All right, so Tyler told me these are supplementary. Ben, how would I set up an equation to show that they're supplementary? Ben, you with me?
Yeah. Would you do
Oh, go ahead.
7x plus 4
Mhm.
plus 50
Good.
equals 180?
Perfect. So Tyler told me that they're supplementary. Ben set them, added them up, set them equal to 180. Very good. So now we just have to solve. So I've got 7x plus 54 equals 180. I minus 54 from both sides, and I get 126. And then I divide, and I get 18, I think. Yeah, I'm gonna stick with that. I had kids in my other class figure out what this angle was equal to. They knew 50 and this angle were supplementary, so they just set 7x minus or plus 4 equal to 130. So if you did the supplementary first and then set 7x plus 4 equal to 130, that's also okay. Awesome. Thanks for the help, Tyler and Ben. Okay, now I gotta find EH. Chantel, can you help me find EH?
EH would equal 8
Good, why?
because they bisect.
Good. Oh, go
If
ahead.
quadrilateral angles. I mean, if they're parallel, then
You're right there.
then diagonal angles bisect each other.
Very good.
I mean, lines, the sides.
The diagonal lines bisect each other. Very good, Chantel. So if it's a quadrilateral, or sorry, if a quad is a p-gram, then diagonals bisect each other. So Chantel just saw HG was 8, so that meant that EH was 8. Just set them equal to each other. Very good. All right, now we got to find Y. How about, Jeanette, can you help me find Y?
Would it be 6y minus 9 is equal to 21?
Perfect. 6y minus 9 equals 21. And Max, can you tell me why we were able to set that equation up?
Not really.
What do we know about ED and FG?
ED and FG. Where's FG? Oh, yeah, there it is. Well, they're parallel. They're congruent.
They're parallel and they're congruent. So we
Yeah.
say they're parallel because they're congruent, we get to set them equal to each other. So opposite sides are congruent in a parallelogram. So Jeanette knew we could just set them equal to each other. That's what I was looking for. So opposite sides are congruent. Add 9 to both sides, divide by 6. Cool. Everybody good?
Yep.
Awesome. On those last two, thank you, Chantel and Jeanette and Max. All right, we got one more box, one more thing to look at. Any questions so far? All right, this one, first one says, is STUV a parallelogram? How do we know? I don't think I've talked to Michael yet. Michael, what do you think? Is this a parallelogram?
Yeah.
Yeah, why do you think so?
Because it has 4 sides. It's parallel on each side.
That's exactly what I want. These two sides are parallel and these two sides are parallel. Very good, Michael. Okay, now it says, what other lengths can you determine in this diagram? Eli, can you tell me one other length that we know?
Yeah, the opposite side of SVTU is 12.
Awesome. And then Allie Armour, can you tell me one other thing we know? Allie, you with me? Allie. Oh, Allie, you better talk to me or I won't mark you present. What about Alberto? Do you know the other thing that I know? What other thing can I mark?
Is TW14
Very good. And how do you know that?
because it's diagonal lines bisect each other.
Awesome. Diagonal lines bisect each other. And then I haven't talked to Marisol yet. Marisol, do you think I can mark anything else?
I don't think so.
I think you're right. I don't think so either. I wish that we had some angles to tell us stuff, but we know nothing else. So sorry, that was a lame question to ask, but I wanted to keep you in the loop. So nope, there's nothing else we know, nothing else we can mark. All right. Thank you, Alberto, Michael, and Marisol for helping me on this. Now, this last question is open to anyone because it says, are there any pairs of congruent triangles? And I think that there are 4 sets of congruent triangles. So I'm going to erase all of this nonsense on here. I can prove these triangles are congruent by side, 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 or side angle, side, and I'll kind of show you on that first one. But after that, we'll just assume based on all the things we know about parallelograms that that's true. Who can see one pair of congruent triangles? Anybody can help me.
VWS and TWU.
Good. VWS, TWU. Very good, Ben. I love how carefully you named that. Those guys are congruent. We knew 12 and this guy was 12 and this is 14 and that's 14. And then I've got these interior angles by vertical angles. You also could have done these sides. There's a lot of ways we could prove these triangles are congruent. I don't have room to like scroll all the way over, but I would write this under letter C if I were you, but I'm just gonna write it next to it. So VWS is congruent to TWU. Very good, Ben. What's another set of triangles that we see are congruent?
VWU and SWT.
Very good, Ty. VWU. I would go TWS if I was naming it with the correct angles. I don't know if you said that or if I just misheard, but I would name it that way. So VWU congruent to TWS. Again, same idea. I've got these angles. Those are congruent by my diagonals. These are also congruent by my diagonals. I've got this vertical angle. So lots of different ways I could prove they're congruent. Very good, Ty. I can see 2 more pairs of congruent angles. Anyone else see them? I'll give you a hint.
Could you do VTS and VUT?
Mm-hmm. VTS, and I would probably go TUV. Those are not very distinct different triangles, but yes, those big triangles we can mark too. VTS, and then TVU. Very good, Megan. Using Megan's thought process, can anyone see the last set?
SUV and UST.
SUV and UST. Very good, Ty. SUV, UTS. So those big triangles on either side work, and then the 2 across from each other on top and bottom work. All right, again, I would have written that all under letter C, but I didn't want to scroll out from that. And then we did determine other lengths, so I have that marked. Okay, I think that's it. Technically, the last 5 minutes would be cleaning bell anyway, so we are going to be done for today. You do have this worksheet though, and it is kind of long. That's in your Schoology folder. I'm just gonna pull it up really quick so you see it. And I will put a link, like a Dropbox up later today. We'll go over this tomorrow and then we're reviewing all class. So if there's any part of this that you don't understand, make sure that you talk to me or we work through it tomorrow because your quiz is on Wednesday and this is a great opportunity to do well and to get your grade up if your grade's not really where you want it to be. So I'm going to stop my share. I'm going to stop